All right, we're going to be talking about theoretical probability today. So if you roll a number cube, what are the possible outcomes? And then add the two fractions below. Press play when you're ready to correct. All right, possible outcomes are 1, 2, 3, 4, 5, or 6 on a six-sided number cube. Adding these fractions, we get 1/4 and 5/9. Right, so we're going to be talking about theoretical probability, something that's equally likely, fair, mutually exclusive, and disjoint events. So theoretical probability is used to estimate the possibilities by making certain assumptions about an experiment. So different from experimental probability, where each of those trials were being done, where we will be estimating more on theoretical, like if you were to do this, what would the probability be? Uses a similar formula though, so there is not a new formula to memorize. So suppose a sample space has 5 outcomes that are equally likely, that is, they all have the same probability. The probabilities must add to 1, so just like a 6-sided number cube or a 5-sided number cube. Okay, so theoretical probability for equally likely outcomes. The probability of an event is the number of outcomes in the event divided by n, which are the equally likely number of outcomes in the sample space. So a coin, a die, or other object is called fair if all outcomes are equally likely. So an experiment consists of spinning a spinner once. Find the probability of each event. So probability of rolling a 4 or spinning a 4. There are 5 equal sections to this. So that means the number of ways you can get 4 is 1, and there are 5 total number of outcomes, so 1 divided by 5. An even number, and our 2 even numbers are 2 and 4, so 2 possibilities out of 5. Okay, we'll go ahead and skip this one. An experiment consists of rolling one fair number cube and flipping a coin. Find the probability of the event. Show a sample space that has all outcomes equally likely. So the outcome of rolling a 5 and flipping a heads can be written as the ordered pair 5, H. There are 12 possible outcomes in the sample space. Okay, you could roll a 1 and get a heads or tail, a 2 and get a heads or tail, 3 heads or tail, 4 heads or tail, 5 heads or tail, 6 heads or tail. And we're looking for 5H. And there's only one of those out of the 12 possible outcomes. So probability of rolling or flipping tails. There are 6 possible outcomes in this event. So tails with 1, 2, 3, 4, 5, and 6. So an experiment consists of flipping 2 coins. Find the probability of each event, 1 head and 1 tail. Okay, so there are 2 outcomes in the event, getting 1 head and 1 tail, and that's heads and tails or tails and heads. So 2 out of 4 possible outcomes, or 1/2. So both tails is 1 out of 4. Stephanie has 2 dimes and 3 nickels. How many pennies should be added so that the probability of drawing a nickel is 3 out of 7? So adding pennies to the bag will increase the number of possible outcomes. So we'll set up a proportion, and we'll let x equal the number of pennies. And then we'll just find the cross products. Subtract 15 from both sides, divide by 3. And we get 2. So two events are mutually exclusive or disjoint events if they cannot occur in the same trial of an experiment. For example, rolling a 5 and an even number on a number cube are mutually exclusive events because they cannot happen at the same time. Suppose you are playing a game in which you roll 2 fair number cubes. If you roll a total of 5, you will win. If you roll a total of 2, you will lose. If you roll anything else, the game continues. What is the probability that the game will end on your next roll? Okay, so if you roll a total of 2, you lose. So it is impossible to roll both a total of 5 and a total of 2 at the same time. So the events are mutually exclusive. So we'll add the probabilities to find the probability of the game ending on your next flip. So in the event where the total equals 2 consists of one outcome. You have 2 number cubes. There's only one way to get a 2, and that would be rolling a 1 on both number cubes. And there's 36 total possibilities, so be 1 out of 36. To win, it would be a total of 5. There are 4 different outcomes, rolling a 1 and a 4, a 2, then a 3, a 4, then a 1, a 3, then a 2. So 4 out of 36. So in order for the game to end, someone would either have to win, getting a 5, or lose, getting a 2. So we'll add those two probabilities together. 1 out of 36 and 4 out of 36 gives us 5 out of 36, or about 14% chance. All right, here is your lesson quiz. Go ahead and copy down the problems. Make sure you're using your formulas, and we will go over these in class.